Assalamualaikum and good morning. I'm Irfan. Today I want to explain the task ones that consists three questions. First, we look at question 1 where it's to find any even functions. So first we got the functions that consist the even functions, and we need to sketch the graph. And if we see the graph is this is a long range, this is the range, and this is the fx. And also we know that even functions bn is b sub n is equal to 0. So we just need to find a naughts and a ends. Based on formula a naught, we write like this and get the 1 per half for a naught. And then we need to find uh, a ends based on the formula givens and get -4 per n pi square. Hence, the effect function for evens functions is equal to uh, fx 1 over 2 plus summations -4 per n pi square cos n pi x. Second question is find any odd functions, and we get these functions where is fx is 3 to -3, and the range is negative pi to pi, and uh, with the periodic 2 pi, and we get the L is equal to pi. So we know that odd function is the fx is negative. So based on the function, we can sketch the graph, and we got like this, where the fx is -3 to 3, and the range is pi to -pi to pi. Uh, since this is odd functions, so there is no a naught and a n. So a naught and a n is equal to 0. So we just need to find the b sub n. So based of a formula of b sub n is equal to 1 over pi integrate -pi fx sine and x dx. So this is sine Fourier series. So we got the b sub n is equal to 12 over pi 2n minus 1, where n is 1 to 3. So the Fourier series of this odd functions is equal to 12 per uh, 12 over pi summations and 1 sines 2n minus 1 over 2n minus 1 x. For the last question is to find neither even nor odd functions, and we got these functions is equal to 3 to -3, 0 to 1, -1 to 0 and with a period of 2. And so we look at the graph and we get like this. And for a naught, we use the formula and we get a 1 over 2, -1 -1 to 1 fx dx and equal to 0. Same also the a sub n is 1 once fx cos and n pi x dx also equal to 0. And also lastly we need to find b sub n, which is equal to -6 per n pi uh, -1 n power of n negative minus 1, and we get the bn's like this. And also, so we can find the Fourier series for this function, where it is equal to summations and 1s, 12 over n pi and sines n pi x per l over l.
For task 2, I choose this equation, which is fx negative 1 and 1, and the range is negative pi to 0 and 0 to negative pi. Let's start by visualizing the square wave function. So, imagine a waveform that alternates between negative 1 and 1 within the interval from negative pi to pi. Alright, for cosine series expansion. Now, let's break down the square wave using the Fourier series. We will begin with the cosine series. First, we calculate the coefficient of n0, and after we integrate this function over its period, which is pi, we get that n0 is equal to 2. And then we calculate the coefficient of an. It turns out to be 0 for all the n value. Therefore, the cosine series expansion simplifies to fx equal to 1 plus 2 sigma infinity n equal 1, 0 cos n pi x divided by pi. And for the sine series expansion, we calculate the coefficient of bn, and after the integration, all bn coefficient also turn out to be 0. Okay, so the sine series expansion simplify to fx equal to sigma infinity n equal 1, 0 sine n pi x over pi. And for the Fourier series combination that have neither both of the value of the Fourier series, we combine the cosine and sine series. So the Fourier series expansion for the square wave is simply the constant term 1, which is we will get fx equal to 1 plus 2 sigma infinity n equal 1, 0 cos n pi x equal pi, plus sigma infinity n equal 1, 0 sin n pi x over pi.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So now I'm going to explain about task 3, which is Fourier series expansion. Before that, let me introduce myself. My name is Muhammad Shahid bin Ismail. My ID number 2023503171. Okay, let's continue for the task 3. The question asks, put any value of fx for period 360 and function value over one cycle, and also find the Fourier series expansion up to third harmonic. So I decided to put any value of fx 0.4, 0.6 and so on to 0.3, and I do a table fx. This will be first harmonic, fx cos x, fx sin x, and also this fx cos 2x, fx sin 2x will be second harmonic, and this third row will be third harmonic. So I just calculate fx cos x, fx from this one, the value, and times cos x. So the answer will be 0.4, and so on. Okay, so for the for easiest to do is using by Excel. Okay, just put the value and drag, so on, and after all, sum up fx, fx cos x, fx sin x, fx cos x, and until fx sin 3x. Okay. To find A naught, the formula is given 1 over 6 sine sum fx. So from that, 1 over 6 sum of the fx, which is sum of fx 13. So I put it here, 1 over 6, 13, and we'll get 2.67. And also to get C naught, 1 over 2 A naught, and the answer 1.084. That for the A naught and C naught. For the A1, first harmonic, the formula is 1 over 6 sum fx cos x. And also B1, the formula is 1 over 6 sum of fx sine x. And get the answer 0.487. For the C1, to get that, we must do a set A1 squared plus B1 squared, and just key in the number, and I will get 0.71. For the alpha one, the formula is tan inverse A1 B1. A1 from the calculation just now, and also B1, and the answer will be 313.57. That for the first harmonic. The second harmonic will be the same calculation and same from the table. So on, and we will get alpha 2 tan inverse A2 B2, and we get 290.48 degrees. And also for the third harmonic, A3 1 over 6 fx cos 3x, B3 1 over 6 sum of fx sin 3x, and also C3, the formula is the same, A3 squared plus B3 squared, and we get 0.70. Also for the alpha 3, we get 191.18. So from that, we can find the Fourier series expansion. So fx will be 1.084 from the C naught, okay, from the C naught, plus 0.710, which is C1 times sine x plus 313.57 is from alpha 1, okay, and also plus from C2 plus C3 sine 3x plus 191.18. Okay. So that's all from us. Thank you.